G'day everyone, welcome to Lubrication Explained. I'm back with my friend Danila from Graco, who was, formerly an Uber driver, but now
That's another story.
Now functioning as a Graco rep. No, ex-mobile as well. Now, what we've got here is kind of like a standard setup that you might see for grease dispensing in the mining industry, so mobile equipment, I should say. So that means that we're not restricted to mining industry. It could also be something like construction, right? Danila has very kindly kind of set this up as a bit of a guide and sort of like I guess a training package, right? To be able to run through all the different system components. So we're going to do a deep dive into this as well as like the injector systems and how this all works.
So this is the grease pump. In the mining, you can see all different kind of power to drive the pump. For example, it can be hydraulically driven pump, it can be pneumatically driven pump, it can be electric pump. So the most common is electric pump nowadays. But if you want, this is the hydraulic version of the pump for the automatic lubrication system in the mining environment, and the reservoir there is 41 kilos. It's a pretty heavy unit. Not only because it's 41 kilos of grease, but itself is very heavy. I mean.
Yeah.
So this is like our newest pump, which we launched a couple of years ago, and this is actually has got the typical mining reservoir size, which is 27 kilos. So it's everywhere you go on a truck. It can be any brand of a truck. It's going to be 27 kilos, 60 pounds also. So this is the compact Dynastar pump, and it's called compact Dynastar pump, not because if it's small, unpowerful, it's like not building up the pressure enough. It's because it has everything compactly located on the pump. So that when you talked about the single line parallel system, you need to have a vent valve, the pressure switch, the low level sensor, you gotta all have this. And this has everything here included. So the compact Dynastar pump has got a vent valve here, the pressure transducer here. So it actually gives you not only like a pressure switch only when there is a high pressure, but actually through this controller, we can actually see exactly the pressure in a grease line right now, how it's being built up. And also the low level sensor there, which actually measuring the distance to the follower plate and giving us, like, for example, right now, this pump is 11% full. So it gives me exactly amount of grease right now in the reservoir, which actually can also give me an indication, well, do I need to top up right now my grease reservoir, or I can wait until next maintenance period? Like, it gives you some sort of an indication. So in a typical mining setup, what we have: a pump, a remote fill manifold, injectors, and the tubes going to the lubrication point. And the controller to control everything, which has to be in a cap so the operator sees what's happening with the system, if it's working or not working. So starting from the remote fill manifold. So
hang on, just so we're clear there, that was remote fill manifold.
Yeah.
First time I heard that, I thought you said remote fuel.
No, remote fill. Yeah, remote fill manifold. Remote fill manifold, which can be mounted anywhere where you can access, it's usually on the ground level so that the person can just easily unlock this dust cap and connect through the quick coupler the grease. So, and the grease cleanliness is also important, not only the oil cleanliness, right?
Yeah, I mean, so that's probably a nice little segue, right? So here, for example, when we're filling up with grease, there is a filter immediately in line. I think this is probably something that doesn't get that much attention in our industry. We put a huge emphasis on oil cleanliness. In the same way that we put a huge emphasis on oil analysis and sampling, but we don't really do it for grease for some reason. For anyone who's been watching the channel, episode 1 of the podcast with Rich Wurzbach talked extensively about grease analysis. We kind of delved into the reasons why it's not very common. I think it should be more common, but that's a whole nother discussion. Now, in terms of oil cleanliness, I think it's, especially in industries like mining, power generation, oil and gas, it's very well understood how strong a link there is between oil cleanliness and asset health. Right? So if you look up, for example, the Noria website, they have these things called life extension tables, where they've looked at data for hydraulics, gears, bearings. I think there's probably a couple more. I know SKF has a very similar tool for bearings, where they look at the ISO cleanliness code and the expected life. So let's say, for example, you're able to improve your hydraulic oil from something like an 1816 to a 1614. Roughly, right? What kind of life extension do you get out of that? Is it 1x, 2x, 3x, 4x, or 5x? So we know very clearly that there is a direct link between oil cleanliness and the asset life. What we probably don't appreciate so much is grease, right? Because a lot of people think of grease as something which maybe retards like contamination, right? So we don't worry too much about grease contamination, when in fact it has just as an important effect on the life of the asset. So one thing, for example, now this is not exactly a grease nipple, but something similar. So one thing I find, for example, is the importance of these caps. What you'll often find on a lot of sites is that the cap to the grease nipple is often just left off, right? Or people intentionally discard them because they don't like the inconvenience of having to put them back on again. And what we get is a whole bunch of contamination that builds up over the grease nipple. And the next time you put your grease gun on that, you are forcing dirt directly into the application, right? So these kind of caps are actually really important. Now in this instance, right, what we're doing is that we are cleaning grease as it's going into our container. So that's kind of like a first line of defense. And then as long as we keep everything sealed, it's, there's no contamination on its way into the application. And so we can sort of maximize the life of our assets by supplying clean grease all the time. Now, one thing that Danila highlighted, and we'll show a photo over the video, is that there is a secondary complication when it comes to grease, which is that the cleanliness can also affect the flow, right? So very small contaminants can actually disrupt the way that pressure builds in the system, which means that in a lot of instances, very small contaminants can cause grease starvation, right? And so if it locks up the entire system and we get starvation of the asset, bearings can fail very quickly when grease is not being delivered to them. So, just that's kind of like a little digression there, but yeah, absolutely. Grease cleanliness is definitely something which deserves a lot more attention and importance.
You got the grease on you. Do you need another one?
No, we're all good. That'll do.
So on that picture that we will put in the video, that actually it's showing us the lower part of the pump where the pressure being built up. So there are a series of check valves, they're like small little metal balls, like keeping the grease flowing only into the one direction, not backwards. So and what happened there is that the small metal part, because of wrong practices of refilling the reservoir, caused a small debris, a small metal particle to actually stuck between the check valve and just the inner tube of the building up the pressure. So meaning that the check valve could not close properly, meaning the grease was flowing pump was trying to put the grease in a line, but because the check valve was not working, the grease was just going back and we cannot build up pressure. So it caused, a downtime because the system alarm, the vehicle says, hey, low pressure, low pressure, low pressure, low pressure. Then we had to go and check, like, is it a vent valve problem? Is it the line is somewhere, cut or I don't know, like blown. I don't know what happened with the grease hose there. So and then we had to disassemble the pump, fully clean it. Then we found out the debris, that we assembled back everything together, and then we started the pump. So it took a couple of hours, to be frank. So because of the small particle. So yeah, it's very important, these small practices, to maintain the grease clean as well. It's very important. So the oil filter, no, not the oil filter, the grease filter, inline grease filter to keep the big debris out of the pump. So the compact Dynastar pump has got like a tube-in-tube construction there, meaning that there is an inner tube and the outer tube. The inner tube is the tube where the pressure is being built up, and the pump builds up the pressure in a line. But this is the compact Dynastar. This is the 12-liter version of that pump. So we have got 12 liter, 20 liters, and 27 kilos, which is the most popular in mining. So this is the cutaway version. So we can see that this is a different type of the follower plate. So it doesn't have any diaphragm inside. It's really nice and a heavy piece of metal over here. So this follower plate actually pushes the grease down in the lubrication system in the reservoir. So it keeps always grease here, the lower part, so the pump is pumping actually the grease all the time, not creating air pockets. So, and when it's happening, when you refill the compact Dynastar pump, it's basically we refill it from the inlet point, and it goes from the outer tube, as I mentioned, because there is also the inner tube which creates pressure in the system. So we create from this outer tube, from the below here. So this is the inner tube, and it has got like we call it a shovel tube there, which actually pumps the grease, creating the pressure. And also this is the outer tube from which we refill actually the grease going from here, from the outer side. So when it goes up, and so it lifts the follower plate up. It lifts the follower plate up. And also you see here on the top, in the follower plate, this is the pin from the auto fill shut-off option. So if I push hard enough, you see, I lift it up. And as soon as I lift it up, you can see here that this indication pin also is being popped up. The grease is full. When it's up, the inlet is closed. And then the grease don't go inside anymore. So meaning that we completed the refill, the pneumatic pump stalls, and we don't have any excessive grease outside of the pump. We want to make sure that we don't get the grease on top of the follower plate, otherwise the pump will be pumping air, and you will have air pockets in the system. Also, the pressure will not be pressurized, so it's going to be another mess with your system. So we have this grease being refilled from the bottom, and the follower plate is going up, 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 and then there is a follower plate. It's a very thick without diaphragm inside, because the diaphragm, we noticed in the industry, sometimes getting flipped over, and you get the grease going on top of the follower plate, and now you don't have grease, now you have again air, no pressure in the system, so it's all bunch of problems, and some people actually tend to remove the follower plate at all because of that, because they said it's just causing more problems than a solution. It probably worked for the hot environment, because the grease is gonna be like very, very soft. But if you're talking about the cold temperature, I mean, now you gotta use the follower plate there, because the grease is very thick, even if it's an LGI0, and it can be very thick in a very cold winter, and you gotta move, and you gotta have something to push the grease down. Otherwise, when your pump will be pumping, it will create air pockets there, because the grease will not have enough time to really close that space which was pumped from with your pump. So it's very important to use the follower plates, especially in the cold environments. So when we solved, we put very thick and very nice heavy follower plate there, so we also remove the chance of the diaphragm going like this and the grease going on top of the follower plate. So the compact Dynastar, yeah, it has the vent valve, the pressure transducer, the low-level sensor, everything here. All we need just to connect the main line. The main line goes through the injector series of injector manifolds. So on here we see not the legacy injectors. This is the newest development of Graco. It's a Graco cartridge injectors. We call them GCI. So they're unique technology right now in the market for the automatic lubrication systems. So we see here two different colors of the manifolds, two different manifolds. So they can be made out of steel with a maximum working pressure of 5,000 psi and made out of aluminum 3,500 psi. So the aluminum one 3,500 psi is more than enough for the dump trucks. 5,000 psi is more big showers with the high pressure of the system. So what is different here, so you notice that first of all, the outlet which we can use to go to the grease points, it can be from the down of the manifold or from the front of the manifold. So you get to choose. So you whether use this outlet or this on the front outlet, and you can also choose put the grease zerk in the other outlet, so that if you want to do a manual lubrication of this specific lubrication point.
Now, just to be clear, so you can do manual lubrication through here, and then if you've got it set up like this one, then your manual lubrication would be through the bottom point, right?
Yeah. So first thing to start with about the GCR is, do you see this color-coded list of different colors? So it's a silver color, the red color, there is a plugged outlet. So actually we are using only 3 points right now. We lubricate only 3 bearings, let's put it that way right now. So here the black one, the gold, the green, this again, it's a bit white, this is the silver, the purple, the blue. So every color defines X amount of grease being dispensed. So by looking at it, we can actually immediately see, okay, these lubrication points receive 0.31. This perhaps receives 1 cc, these 2.62. So depending, like if you look at the manual, like what the color means. So we can actually define what the amount of grease will be distributed to the system. And comparing to the legacy injectors, which we have here, for example, we have the round ones and we have got the rectangular ones. So for example, in the rectangular ones, you have this adjustment nut over here, and you can see that you can also adjust the output by, making it shorter and longer. You can adjust the output also here. But the problem there is that you are a reliability engineer, you want to reduce the lubrication consumption because you find that you don't need so much grease on your pins, it's more than enough. You want to reduce the consumption. So you put it close, you close it, you count the counts, you take the manual, like for example 3 full turns, you reduce the amount, and then you again, the truck leaves. And the typical truck may have like 35 lubrication points, so you have to adjust all 35. So it's time consuming. I mean, like, and if you have got a fleet of 100 trucks, I mean, that's a lot of time. But what will happen if a smart driver or someone else just comes there and says, no, it's too little grease, I don't want to stay on downtime because I'm being paid for the amount of tonnage of I'm driving, I'm putting to the plant, and he wants his vehicle to run, he doesn't want any problems to stay in the maintenance on the downtime, he goes and he, opens them fully. I've seen in the field they like this even, they can keep it like this, so it's a full open injectors. It's possible with Graco injectors because the indication pin, which actually shows that the system is working, is going downwards here, unlike it can be upwards in some other systems. In our system is going downwards, so we can actually keep even like this. It would work, but it will be all open, so the maximum output. And then this poor reliability engineer should go and just do all over again. And he first need to find out, hey, like, hasn't been even changed or not?
Yeah. Now I should just say, with I guess what Graco is calling the legacy injectors, which are reasonably common in the industry, right? You can actually have visual indication of let's say the amount of grease that's being injected. They have these sort of like coloured sleeves that you might have seen around. So I'll see if I can put this in front of the camera, right? So this is probably going to be a little bit out of focus, but these coloured sleeves, which depending on their height, that can tell you where the position of the adjustment screw is, and therefore how much grease is being dispensed. Now, there are sort of like different versions of this, right, which are, of course, color-coded. I'll see if I can get some of these out. So let's say, for example, I could have, a gold one, slightly different color, and obviously because it's much shorter, then the adjustment screw is in a different place, and therefore there is a different quantity of grease. Now, there's a couple of issues with that. First of all, and I've seen this in a couple of my customers, is that these tend to be not used all that much, and where they are, in some cases I see them discarded. So it's not really kind of like a fail-safe system. The other thing is that even if you have these sleeves on, you can actually still move the adjustment screw up. So you still can unscrew it and therefore dispense more grease than is allowable by these sleeves. The only other thing I'd say about these kind of legacy ones is that they are a little bit more analog in the sense that because you can turn to any point with the adjustment screw, you have an infinite combination of grease kind of dispensing options, right? So you can do quarter turn, half turn, an eighth of a turn. To be honest, even though that is technically an advantage of these legacy systems, I don't think anyone is really being that precise about how much grease is being kind of injected into the system. And so to me, I mean, I quite like this new system that Graco's come up with, which is in some senses kind of tamper-proof, because once you have these kind of color-coded versions on, it's really not possible to have these inject a different amount. There is actually one way that they can deliver double the volume, which is, as you can see here, where you can connect two of these ports together, right? And that's additive. So effectively, you can add the quantity of these two together, and what you can see down here is that there is a single line out, which is, in a sense, well, in this case, it's almost doubling the volume that comes out.
Yeah, and if you want to change the output, you gotta change the sleeve. But also it gives you a benefit because, let me take also the full manifold here, the demo one. So it gives you actually the benefit that even if it's mounted upside down over here on your vehicle, on your truck, you can just pressure wash to clean it a little bit, and you don't need to climb to count the turns. You just look at it, and by the look you see the color, and okay, that's point set on this amount. If you want to increase or decrease, you just change this. So it's really easy to change as well. I mean, it's relatively easy to change also this code. If you look at the legacy injectors, like a round one or rectangular one, so they give a maximum output on 1.31 cc per injector, and the cartridge injectors can give you double the size of that. So one cartridge can give you 2.62 cc per shot. But also there is an XL version. This gives you a 5 cc per shot. You might have seen this on the big shovels, on the bucket pins, but you can see it's 2 times bigger in size. So you might as well just cross-port 2 cartridges and you get the same output, and you get less footprint and less weight. We also made this manifold because we call them legacy injectors, because these round rectangular injectors, they're all over the industry, all over the place. So we still, That's why we also, even for the customers who wants to experience the benefits of the cartridge technology, we also made, the threads, for example, the inlet, the same, like 3/8 NPT with your legacy injector. So it's the same manifold like this, for example, where your injectors are mounted, the same thread here, the same 1/8 NPT outlet, so the same threads. Even the mounting bolt pattern is the same actually with the legacy injectors, which is here, you see. So it's I can easily drop in, replace the legacy manifold with the cartridge manifold.
And that style of kind of what are you guys calling that one? The legacy injectors is pretty common across both the Graco and non-Graco versions, right? So it's a reasonably common design that is common to the industry, and so the fact that this is kind of like backward compatible in some senses is a good move.
Yes. So also, but the biggest benefit there is like mining is all about time. If we want to save on time on the maintenance, increase the planned downtime, remove the unplanned downtime, and increase the maintenance that we gotta do on the vehicle. And these injectors, I mean, they've been replaced quite some time. If you really take care of your equipment, you replace them quite often. Maybe 2 times a year or once a year you may replace them, depending on what is your practice. If someone is doing like upfront before they fail, like maybe they do like every 6 months they replace them, or every year, or every 2 years. So it depends on the conditions that you're working in. So to replace this, can you imagine? So it's mounted upside down. So you have got the hose connected to the grease point right now. You have more injectors here, and you want to replace it. So you have to, if it's a big vehicle, big truck, if it's up there, you need to climb up there on a ladder. You need to disconnect the grease line. You need then to disconnect the injector. And while you're disconnecting this, all the grease line is all, perhaps if you remove the manifold, it's all maybe in grease, in dirt, in dust. You remove injector, you put a new injector, you put a new injector again, and then you just connect back the line. There. Now you replace it. But then you have to set up again the adjustment nut. So if you're really following the practice of the amount of grease, you do that, and then you can go. The cartridge technology, so here you can actually see that this is the outlet is here, the second outlet is here, and it's all built in manifold. So if you need to replace the cartridge injectors, all you gotta do is remove the cartridge. Put a new cartridge, and that's it. You don't need to disconnect any lines. You don't need to touch these lines. You don't even need to adjust again, because remember, you have got a color-coded, hard mounted there. It's always there. So it's always the same output. So you just easy replacement. Anyone can do it. So if it's even, it's any maintenance specialist, even driver of the truck can do it, because all he has to do is just take a 24 socket and just do that. And then it saves a lot of time. On maintenance, just replacing the cartridges.
Now, it's not shown on the inside of this demonstration model with the cutaway, but obviously there's a whole bunch of seals, right, that help distinguish where the grease should go. Probably the only other thing to point out on here is that if the seals fail, right, then you're going to get a small amount of grease that will weep out of these ports. So there's an individual one on each of these cartridges. The other interesting kind of feature on these is the firing pin. So on here, I mean, for starters, it's handy that it's colored blue, because often these things are not colored, and it's a little bit difficult to see when they actually fire. But you can see up here, so these ones will poke up, right, when the grease is fired. Now, on the legacy systems, which is not just for the Graco systems, but for others as well, generally what you'll see is that pin will move. In the case of the Graco system, it'll move down, right? So that's how you can tell where the grease is actually being injected by one of these. So similar concept, right? So, which is in some senses good because everyone is used to it, but in this case, the pin is going to go up.
So now, also, we need to control it. So we have the pump holding the grease. We have the measuring devices, which are metering devices. So they meter the amount of grease going to the lubrication points under pressure. We also have to control everything. And this control is GLCX controller, which has been mounted into the cap. And you can see here that in 10 minutes, 12 seconds, it will start the lubrication cycle. Right now, it's 11% grease full inside the reservoir. So because of we use a low-level sensor, not a switch, but a sensor, it actually measures how much grease we have there. It's 11% there right now. And also, if I start the system, you will be able to see here what is the current pressure in the system. So it's not only the pressure switch which reaches the high pressure and tells stop the pump, open the vent line. It actually tells you how the pressure is being built up, because I've seen in the field troubleshooting that the pressure may start like at 50 bars and now it going beyond that. There is something happening in the system that the pressure it's being built up but not enough. And that's also the problem of debris potentially in the system, because I cannot build up pressure. Because if you cannot build up pressure for the X amount of time, the system stops. I mean, it gives you low pressure, the system gives a fail mode. So what we can also do with the GLCX, which is a very smart, I mean, there is actually an app for a phone that it's called Autoloop. It's a Graco Autoloop app. So, and if you take a look at it, like from your phone, it's a Bluetooth connection to the my controller right now. So you can see here, this is the my controller mining GCI, I call it. I connect to it. This is the controller. I can also see here the 11% level of grease inside. I can also run tests of the system. I can run diagnostics. It tells me in 8 minutes it will start the system, but also I can start the manual run. Let me push the button. The pump just started. And you can see here the pressure in bars. So it's 2 bars, 7 bars, 13 bars. So the pressure is being built up in the system right now. You can do it remotely. As soon as the pressure is reached, it stops. So, and the interval, 60 minutes right now. So in 60 minutes, it actually will start again. I can also run diagnostics here, actually, and see the temperature, the pump current, the last configuration change, how many lubrication events, lubrication runtime, what kind of alarms, how many of them. I can also see, for example, the alarm time in total. It was 24 seconds in alarm mode. Then I can see also the very interesting feature here, which is the average lubrication time. So it tells me, in average, it takes 18 seconds to build up pressure. It's very good for troubleshooting in the field to know, okay, how much actually time it takes for me to lubricate this piece of machinery, if it's 1 minute or 2 minutes, because it also, in a sense, shows the pumpability of a grease. Because the shorter the period of time, it means easier for the pump to build up pressure, faster for the pump to build up pressure, meaning the grease is flowing better. I can also see here different temperatures, like minimum, maximum temperatures. I can also see how much time it's been used. I'm below certain amount of temperature or between 10 and 20 C. So it's a lot of data here. Also, I can see events here. Every problem that has happened, date and the time. There was alarm for the low level, for example, or something else. I can also change the date. I want to see last week, last month, last day. I can choose also not only errors but events. I can also actually check, the lubrication started, lubrication finished, when, if someone pushed the manual run button, which is a common, someone tells, hey, I'm using a lot of grease with your system. But probably because the operator is sitting in the cabin and pushing the manual run button all the time. So this system tracks everything, and we can easily share it in email and CSV format to your email from your phone. It makes very easy troubleshooting and actually allows you to calculate exactly the amount of grease, because we know how much cycles we've done and we know what is the output of per lubrication point with GCI. So we can actually really do a nice study and really reduce the grease consumption on your piece of machinery smart. But the interesting thing also, because this controller is not only time-based on and off, it's interval-based. So we actually tell the controller, I don't care how much time you're going to spend on building up the pressure, just maintain 1 hour interval. Just lubricate my machine every hour. So meaning that if today it's a pretty warm weather, it's very nice, and it took 1 minute to lubricate the vehicle to build up pressure, then the controller himself will adjust the time to time off of 59 minutes. Because it took 1 minute to build up pressure, we have 1 hour interval in the settings, and we need then 59 minutes of time off. If tomorrow is getting colder and it takes 3 minutes to build up pressure, then the time off will be 57 minutes. So the controller will adjust time off himself to maintain 1 hour interval. So it's every hour so that we lubricate, because interval is time on plus time off of the pump.